Hello again, Geometry 5.3, Graphing Areas and Scale Factors. So this is the last activity in this lesson. An artist painted a 1-foot square painting. Now she wants to create more paintings of different sizes that are all scale copies of her original painting. The paint she uses is expensive, so she wants to know the sizes she can create using different amounts of paint. Suppose the artist had enough paint to cover 9 square feet. If she uses all her paint, by what scale factor can she dilate her original painting? I just want to go back to the original question. An artist painted a 1-foot square painting. So if the base and the height are both 1, the area is going to be 1 times 1, which is 1. So it's a square, the base and the height are the same, and the area is 1. Suppose the artist had enough paint to cover 9 square feet. So if she could cover 9 square feet, if she uses all the paint, by what scale factor can she dilate the original painting? So if I want to go from this painting to this painting, what did she multiply the sides by? And I think it had to have been 3, right? If these were both 3, 3 times 3 will give me that 9. So if she multiplied the base and the height, the dimensions by 3, the scale factor K would have to be 3. If you want to call it K or if you want to call it scale factor, it doesn't matter. So now we're going to complete the table that shows the relationship between the dilated area X, so this is what we're going to call X, and the scale factor Y. So this is going to be a little algebra for us right here. So that could be good news or bad news. If the dilated area, if the area after the dilation is 0, what was the scale factor? That had to have been 0. If the scale factor, if the dilated area is 1, so if my original triangle had an area of 1 and the new area is also 1, the scale factor didn't change. It was, you could say it got multiplied by 1 and it stayed the same. If I had a dilated area of 4, what could the scale factor have been? So I think if it was 2 by 2, 2 and 2 would have given me the 4. So the scale factor had to have been 2 in that case. If it was 9, we already did 9, the scale factor would be 3. If this dilated area was 16, what would the scale factor have had to have been? Well, what times what equals 16? I think that's 4 times 4. So if I multiplied the original painting with a scale factor of 4, then I would get that area of 16. So there we go. On graph paper, plot the points from the table and connect them with a smooth curve. So let's see. We have 0, x is 0, y is 0. That's this point right here. When x is 1, y is 1. So that's this point right here. When x is 4, when x is 4, y is 2. So 4, 2 is right here. And then we have the point 9, 3. And when x is 16, that's over here, y is 1, 2, 3, 4. And it says connect these with a smooth curve. I'm going to try to make this as smooth as I can. Oh, man. Let's try that again. Okay. Good enough. By the way, this is the equation of the line y equals the square root of x. I don't know if you recognize that from algebra. We're just taking all of these numbers, and when we square root them, that's how we get the new number. So if I take the square root of 0, that's what I'm getting here. If I take the square root of 1, that's 1. What number times itself equals 4? The square root of 4 is 2. What number times itself is 9? The square root of 9 is 3. What number times itself is 16? The square root of 16 is 4. So that's what's going on here. We're just taking the square root in general of whatever x is, and that's going to get me to y. Using the graph, let's estimate the scale factor the artist could use if she had enough paint to cover 12 square feet. So the square root of 12 is not going to be a nice number, but let's use the graph here. If I wanted to cover 12 square feet, then the scale factor had to have been somewhere between 3 and 4, right? So, your guess is as good as mine. A number between 3 and 4. I don't know. Let's go with, if we're estimating, the scale factor is probably about, let's just say 3.7. It's probably actually closer to 3 than it is to 4, right? Looking at that. So let's go with 3.4 or 3.46. I don't know. Number 5, suppose the painter had enough paint to cover 1 square foot and she buys enough paint to cover an additional 2 square feet. How does that change the scale factor she can use? Well, if you bought enough paint to cover 1 square foot, the scale factor had to have been 1, right? We already said if you had 1 square foot, the scale factor was 1. But if it was 2, then we have a total of 3 square feet. And that's somewhere between 1 and 2. So for number 5, I'd say, how does that affect the scale factor? The scale factor is somewhere between 1, if it's 1 square foot, and it looks like, I don't know, 1.7? And number 6, suppose the painter has enough paint to cover 14 square feet, and she buys enough paint to cover an additional 2 square feet. How does that change the scale factor? So the scale factor, we go from having an area of 14 to, if I add 2 to 16. So the scale factor has got to be between, well, if I can cover 14, that's going to be somewhere between 3 and 4. So, I don't know. It looks like it's closer to 4. Let's just estimate 3.7. I don't know. And if it's 16, well, we already know that's then the scale factor had to have been 4. So the scale factor has got to be between 3.7 and 4, if she adds 2 square root units there. So that's it for this lesson. One thing we can do here, by the way, is I can find the exact areas of, the exact numbers here for 4, 5, and 6. I said that y equals the square root of x. So if x is 12, if I'm covering 12 square feet, then the scale factor is going to be whatever the square root of 12 is, which is, let's see how close I was. The square root of 12 is, oops, 3.4641. Oh, wow, so I was really close. As they say on TikTok, I'm a savage. Number 5, if we had, let's see, if I started with an area of 1 and I got all the way up to 2, so that's a total of 3. The square root of 3 is 1.73205. It goes on forever. And I said 1.7. Yeah, I'm pretty good at this. And then you can do the same thing here. The square root of 16 I know is 4. The square root of 14, you can put that in your calculator and see if it's close to what we approximated. The square root of 14 is 3.741, I don't know, 7-ish. So yeah, we were actually pretty close with our estimates in our graph. So that's it. If I know what the the dilated area is, and I want to find out what the scale factor is, then I can just take the square root of that number in this case, and it turns out to be pretty straightforward. If I know what the scale factor is and I want to find the new area, then I just have to multiply that area by the scale factor squared. So this is just going forward and backwards between those two problems. It helps that the original figure had an area of 1. Uh, if the area was different than 1, then we'd have one more step here. But anyways, that's all for lesson 5. Thanks.